indicators. So I might just delete that or see what works.
Is it at the end?
Yes, like the ones.
You want me to just delete it and upload a new version?
Yeah.
All right, cool.
It's the next step. First next step. Next step. We just go new last couple.
All right, folks, it's about that time. We're at the TLS session at IETF 102. I guess I want to start by saying there's this new person to my right. His name is Chris Wood. He's our new co-chair. We let it go to the list.
Thank you.
He says that now. So this is the note well. It's Monday, so you might not have seen it. Take your time. Basically, the gist of it is if you say anything at the microphone, you're going to be recorded. You're being recorded now. If you have an IPR disclosure, you need to disclose it. That's one of the reasons why when we talk about pretty much everything on this agenda, it all has a draft. So that you have to go through the process of clicking the buttons to make sure you understand the IPR rules. Figure out this. Look at that. Requests. Luckily, we already have a minute taker. We have a Jabber scribe. The blue sheets are currently going around. Please state your name at the mic, and let's keep it professional at the mic as well. I'll just get this right. So this is our administrivia for our agenda bashing time. We have 2 sessions today. Monday is what we have here. We moved a couple of things around based on an early agenda bash from Victor. If you wanted some extra time. Anything else?
No, that's it.
And we have more on Thursday. Originally, we also had encrypted ESNI today, or encrypted SNI today, but we decided to move it because it's going to be a long and lengthy discussion, and we thought it would be best to kind of time out it at the end there. So next, the document status. We have 2 documents in Auth 48 right now. The TLS 1.3 draft is going through the process of getting the updates done, and hopefully we'll get that done fairly soon. And obviously the ECC for Cypher Suites for TLS 1.2 and earlier is also going through. We have 3 other documents that have been approved by the ISG, and they're kind of waiting through the cycle. Another draft that we'll be talking about later today is the DANE record for DNSSEC authentication, chain extension for TLS. We have an IETF last call going now for the example handshake traces. And exported authenticators we're also going to talk about today, which is gone through working group last call. We're just trying to make sure we have all of the outstanding comments addressed. And I know that Christian Wheatma isn't here, but basically the issues and requirements for SNI encryption and TLS, this draft was split. So last time there was solutions and as well as requirements. We decided to split the last time, and the actual issues and requirements draft is ready to go. The only reason why we haven't hit the button on that yet is because we have all these other things in process, and basically we were juggling too much. And we have other drafts in play. Rich?
Yeah, Victor requested that the DNS slot be moved, the DNS item be moved back to its original slot. FYI.
Fine, we can move it. He wants it back. So he said that in the chat. Okay, great. So we can bash that. So that essentially we're going to do exported authenticators first, then we'll do the DNS chain extension stuff, and then we'll talk about DTLS. So for those why we're doing it this way is because these drafts are working group last call, and we want to make sure we prioritize them first to make sure we get through the issues. All right. So first off, Rich, you're up. The down button. Okay.
Wow. I'd like to thank all the little people. Okay, so in April, so this is just, some numbers to impress. In April, we turned on a public beta for TLS 1.3, and we told, all of our customers, if you want to do it, go to the UI and make these portal changes, config changes, because this was like the first time where our life cycle synced up with the browser's life cycle in terms of the drafts. I did a snapshot every 5 days, and by, under a month later, we were seeing 650 million connections a day. Now, the number of people who were enabled this is like in a round off error in terms of percentage of our customers, it's 0. The other interesting thing about the chart is the dips are the weekends. which means people are using this, whether they know or not, in production for real world work. It's been kind of stable. So a couple of people have come in and out of the beta. And I think Firefox is now draft incompatible with us. But in terms of traffic, this is like, 1 or 2%. But that's not bad considering that it's, as I said, 0% of our customers. Can't give you any more numbers than that, sorry. The most other interesting thing for us is that nobody reported any incidents. And in fact, we went back to our support teams and said, really, nobody's complained, it all just works? And well, nobody's complained. So anyhow, I just wanted to show, we're now averaging about 700 million connections, handshakes a day with TLS 1.3, which is pretty neat. Pardon me?
Talk about deployment.
Yeah. So if you want to change the protocol to enable man in the middle, the cat's kind of already out of the bag. Thanks.
Hi, this is Nick Sullivan, Cloudflare. I can share some additional numbers from our side, which are relatively similar. We had deployed TLS 1.3 of various draft versions starting a year and a half ago. It's now up to, in terms of number of percentage of requests served by Cloudflare, 5%. So 5% of requests are TLS 1.3. And it's enabled by default for all customers who didn't explicitly disable it. And so I can't give a apples to apples number of connections per second, but it's a pretty decent percentage.
Nick, are you 23 and 28?
28 only.
That's public.
Actually, no, 23 and 28 right now.
Yeah. So Rich Sauls, there was a question on the mic, what percent of our total traffic is that? Under 1%, and we're 28 only.
Yeah. So we should be compatible with you now, we're 28. Right, so I guess this is our telemetry data. These are order of magnitude estimates. Basically, our clients send back telemetry and, you have to filter out all kinds of outlier problems, because if you don't, you get people reporting 8 million connections a day and they're presumably lying. But so this is a 1% sample out of our clients. And then the methodology is that I take clients, I bucket them by client ID, and then I treat them as that. That gives you a fraction per client of 1.3, and then you average all the fractions to normalize by client. And so anyway, this shows us actually no 1.1 in preparation for Stephen's presentation, not much 1.0. And we're at a little over 3% 1.3. This is release. Beta shows more like 5 to 7%. Don't know why. I wouldn't trust, as I say, I wouldn't trust these numbers to within 1.3. So I wouldn't trust these numbers to within more than a factor of 2 or so. But obviously we're getting quite a bit. I'm actually honestly, I'm surprised Nick is seeing so little. Given that Chrome and Firefox are both 1.3 by default, I'm surprised we're not seeing more. But we can debug that later.
And that's an excellent segue into our next presentation. Sorry, I'm just learning to use the new tools.
Tomatoes on the front row then. 'Cause I got Hi, so, that's loud, sorry. Is it time to deprecate TLS 1.0 and 1.1? And we're trying to get the bottom of that. And thank you to everyone for providing statistics on the list and information on problems that you foresee. So this is short because we'd like it mostly to be discussion. Go ahead, please. All right, so, good, it's right here. So we do want meaningful statistics across different applications. We've gotten some that are non-HTTP. The Apple ones posted yesterday or today, thank you, included non-HTTP, so that's helpful. examples of systems or applications for which no upgrade path is available is of interest, and if they're showstoppers. So are they systems that if a major vulnerability was announced and your configuration possibilities didn't cover it, would there be a big issue? Or could the system be isolated? Or even just saying what this is, maybe the vendor will step up, right? So putting it out there. And that pretty much covers that next section. Okay. And are there other considerations we should be thinking about? So, I'm thinking statistics, showstoppers to help us figure out timelines. And of course, if it's adopted right away, it doesn't mean it's going to be published right away. And then even when it's published, we've had several vendors say they're going to continue to support this in their next release. Like Rich had said that for OpenSSL, they're going to be putting out the next version. So for the next 5 years, both of these versions will be supported in OpenSSL. So you have your bases covered for a bit to help us with this deprecation, but the numbers we've even seen just with the 1.3, they're pretty low.
Hi, Jeff Hodges, PayPal. Something we noticed in our PCI mandated upgrade here over the last couple of years is that in the case where somebody doesn't also operate the client side, okay? It's like they're out there on their own, you're offering service over the net from your server. There's no way to tell when you upgrade what happens other than warn everybody and then have a flag day.
Right.
For some percentage of your customers, and this really sucks.
Yeah, I actually had read the page from PayPal and a few other vendors when they did this cutover for PCI and their flag days, and that was
and
interesting.
You have to have many flag days, yeah. and try to roll it through your customer base, and also you may not catch everybody, right, because they may make changes in between the windows where you're trying to do your testing and such. So, we'd like to put our heads together with various interested parties, self-nominated, and, brainstorm if there's something we can do in this context, IETF, to come up with something to make this easier for when the regulators go, oh, by the way, you're migrating to 1.3. For example, or everybody has to go to 1.2. Right now they say 1.1.
Right.
We had our customers go and merchants go to 1.2.
Right, and the reason we bundled in 1.1 is because there's such small numbers for deployment, so it just seemed to make sense to just bundle it in there because people should be going to 1.2 as a minimum, not 1.1 if you're making a move.
Right. So anyway, at this stage of the game, if anyone wants to chat about this, feel free to reach out and tug my sleeve. We want to talk about it for the foreseeable future and see if there's something we can work out.
And Jeff, what's your name?
Some definition of we. Jeff Hodges.
Yes, so Martin Thompson, I think the ultimate answer here is going to depend a bit on the deployment context in which we're talking about. For the web, at least, we're starting these discussions now. We're seeing, as you saw on Eka's slide there, on usage rates, we're now getting pretty close to the point where we can probably start turning off TLS 1.0 in web browsers, at least. Maybe not straight away, but 18 months' time, I think it's perfectly reasonable to expect that to sort of quietly go away. And you're actually seeing sites now just deploying 1.2, and that's something that sites can do already, and that's not a big problem for them because browsers tend to be evergreen and they all have TLS 1.2 enabled, and there's not really a whole lot of point in trying to talk to someone who's only got TLS 1.0 because they also probably have a bunch of other problems at the same time, and so that's okay. List. But the discussion on the list was pretty clear that there's a large population of use of TLS 1.0 in other contexts, and it's going to be a lot more difficult for those contexts to move. And so I don't think it's a problem for us publishing a document. I would be perfectly happy having this document published tomorrow as a statement. I think this organization can make that statement now, and that has an effect on the actual rates of use, which would be positive. I don't think it needs to be called die, die, die. This is really just craft, and we'd just like to get rid of some tech debt. So it's not really that dramatic.
Right, well, we just put the die, die, die because all these drafts that we deprecate have been die, 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 right? So, but the media picked it up as a very strong statement, and I was surprised by that too.
Yeah, it doesn't need to be that strong, but that's,
Yeah, well, because
the name
people.
of the draft doesn't matter, so, yeah.
So I agree, because vendors will continue to support it until their customers are off, but this is a way to help get customers off these older versions so you could reduce your footprint of code. And we have that too, right? Where I work at Dell EMC, it's the largest IT company, right? We still have some customers on 1.0, even though our official stance is that it's been deprecated.
I think it's important for the IETF to send a signal here, and publishing this now is a pretty effective way of doing that. So I'd be sort of on board with doing a little bit more of the groundwork that you're talking about, but then just publishing this when we're ready to publish it, which hopefully is soon.
Right, and just helping with the deprecation curve to speed it up. It may not make it cease, but.
Over here.
Yeah, Daniel Franco, Bank of America. So I guess my point is similar to Martin's in that I don't think we need to consider usage statistics at all in this decision, because even if it, no matter how many users it has, our putting out a standards track document entitled die, die, die does not actually RM all those implementations and make them die, die, die. Nothing actually breaks. So what, the only thing that should make us consider not publishing something like this is if there are some actually architecturally sound reasons to keep these protocols around. If it's simply a matter of technical debt sitting around that nobody's bothered to pay off. So for example, by far the most common problem I find why these protocols can't be disabled is simply that I find that a programmer misunderstood the OpenSSL APIs and hard-coded a particular protocol version without meaning to. So if we're just dealing with those sorts of reasons, and I think we are mostly just dealing with those sorts of reasons, then we should not hesitate to publish this.
Thank you.
Thanks.
Eric Sorolla, thanks for publishing this. I think it's a great idea. I was going to get up and say what Daniel said, which is that, what we're telling people is the IETF no longer thinks these are safe protocols, and we should be moving away from them. And that's the principle why we did one too. So I don't think it's a problem to say, like, we understand you may have reasons why it's hard for you to move away from them, but we advise you to do so. It's the position I think this is taking. So I think that's fine.
Right. I mean, should we add something for some text even for people? Well, it's not even adopted yet, but to explain for enterprise networks and people that might have trouble what it means. Because I think just IT people being overtaxed is probably what we'll hear most about.
Brett Jordan, thanks for publishing this. I think it's a great idea. I agree with Ecker and Martin. I do think the fundamental problem is not whether or not we publish this and we come out with a public stance saying the IETF thinks these should go away because they should have gone away a long time ago. It's the fact that most people that implement TLS don't have a clue as what they're doing. They go out and they search Google and they find something and they just say, oh, this is what will make it work. And they just copy and paste that in and boom, it's off it goes. So that's our fundamental problem with a lot of this. But thanks for publishing it. I do think it's a great idea.
Yeah, and that was part, folding back into my company and then seeing people, our product teams had to make these decisions, and then all the customers would have these 4 choices soon, and that just becomes more complex. So reducing the number of choices I thought would be helpful, which is one of the reasons we started this.
After Nalini gets up, we're going to clip the line.
This is Daniel Kahn-Gilmore, ACLU. So +1 to what everyone's been saying, that we can afford to publish this without driving all the numbers down to 0 first. Publishing this will help us drive the numbers down to 0. And I also want to observe that there are multiple audiences for documents like this. And if we're careful, we can make sure that the document is useful to all of them. And when I think about different audiences, I'm thinking about both implementers and deployments. And if the document actually provides clear advice for implementers, such as, given the state of the network today, you may not be able to remove this entirely, but we recommend that you do the following things, right? So like Cypress prioritization, version prioritization, warnings, logs, warnings out to the other end party. That we can provide useful guidance to implementers that will then themselves provide additional spurs to deployments. So we publish this now in order to drive adoption. We don't wait for the adoption to drop in order to publish it.
Eric Niger and Akamai, and I think also following on with those, I think the focusing on, rather than kind of the die, which I'm sure will come up at some point, but for now, I think a lot of it is really trying to get implemented. For example, if they're doing something new, to not even think about implementing TLS 1.1 or 1.0 and new things they're building. In looking at statistics on this, any of the numbers that kind of like, here's an overall aggregate number are a little bit misleading. I was digging into some ones I have access to and was seeing that it ends up being you have a distribution of different use cases. You have some use cases where people have happily turned off everything other than or below TLS 1.2 and things just work fine for significant fractions of customer sites. And then you have other cases at the other end of the spectrum where you have significant numbers of sites where 80% of the traffic is still using old versions of TLS, oftentimes because they have custom client software, and we'll just need to be a little cognizant about not wanting to force everyone just pull the plug off pull the rug under some of these custom implementations where their use cases with 1.0 might be better off than the alternatives if they tried to do something even worse.
Yeah, Nalini Elkins, Enterprise Data Center Operators. I actually find myself in agreement with a number of things that have been said. I think Jeff's idea of how do we reach out and educate people to do this, and also what our friend from the ACLU said about, I find myself in total agreement with you, surprisingly, is yeah, we need to have guidance for implementers, but it's a tricky problem. People really are trying. It's not so easy. That's, as I said, so any help, and it's the client software at these ends, and so maybe reaching out to those vendors. I mean, I'm just throwing people, that there's a ton of these guys out there. And so that might be, but it's a somewhat smaller subset. So some kind of reach out, and I'd be totally up for a group that got together and thought about some of these things.
Yeah, even if there were blog series and the media picked this up within 12 hours of when it was posted, even though I didn't post it to the TLS list. So I think when it's finally published, it'll be highlighted pretty broadly.
So Jeff, I clipped the line.
Just quick follow-up. Thanks, Jeff Hodges. I want to echo what DKG said. I support the draft, but we, TLS Working Group, could do a better job of figuring out how to facilitate deployers in their upgrade efforts.
That's good. All right, so I'm going to do this. Can I have a show of hands of who's actually read this draft? Wow, so a fair amount. My plan is that we're probably going to run a working group adoption later. I should note, I tried to do this 5 years ago. I got my head handed to me by the working group, so I'm glad I can put it back on. The second thing is we had this working group called Utah in the art area, right? And they, years ago, in like 2013 was when this work started, and I guess in 2016 or something, they finally put out a draft that said, hey, you should be doing 1.2. So this is not new. This is something that we should just be doing. So that's it. So, all right, guys, great. Next is Nick, I believe. There we go. Dink. Nick, you're up. Make it bigger. I think this is the right one. You uploaded it, right?
Hi, I'm talking about exported authenticators, which is a draft that I'm currently working on. Next slide, please. So background in this is an exported authenticator is a method for one peer in a TLS connection to assert ownership of the private key of an additional certificate. And this can be either the client or the server. And this proof can be sent out of band, although it's bound to the TLS connection that it was originally established with. This work was motivated by the HTTP BIS working group's additional certificates draft, which is a method for enabling post-handshake client authentication at the HTTP layer, as well as additional server authentication. This was adopted last year, and the latest update to the draft was earlier this week. Last IETF, there was a formal proof of security presented and a paper published by Jonathan Hoyland. All right, so between the last IETF and now, this went through a last call, and there were several comments. The main request, or the main change that was requested during the last call, was the idea of an empty authenticator. As the draft was written before, every exported authenticator was tied to a certificate in a certificate chain, and there was a need for a server to do a explicit refusal for a given authenticator request. And so this was added to the draft in response to these comments. Next slide, please. All right, so in any case, that's sort of where we stand right now. There hasn't been a lot of traffic on the mailing list about this, but there has been some discussion, and I propose the next steps would be a new last call for this draft.
Does anybody have any other outstanding comments against this draft that we need to consider? Because otherwise we're going to do exactly what Nick is asking for.
Jonathan Hoyland. If we're going to do another last call, it'd be really nice if in the spontaneous certificates, we added a requirement that they be unique. The certificate request context can be arbitrary at the moment. Making it be unique would make life easier for me.
This would be easier for the analysis?
Yeah, it makes the analysis easier, because if it's arbitrary, then it could be all kinds of strange things.
And this is unique from one peer to another, or unique
within
globally?
Unique within the context of the connection. Because it can't be unique globally, because the certificate request context is set to empty in various cases.
Right. Is there not a problem with two authenticators that could be generated at the same time being sent across? A parity bit would solve that?
It doesn't matter if they're sent by opposite parties. It's whether a server sending the same two different certificates with the same CLC.
Certificates or?
Sorry, two EAs with the same CLC. Because at the moment that's allowed, and it makes the proof complicated.
Okay.
Mike Bishop, Akamai, and author on the secondary search draft. We already have the requirement that the context be unique within the connection, so adding that at the TLS layer would be fine. Now, we do need to be able to generate multiple authenticators for the same certificate, potentially. I presume that's not a problem.
It doesn't matter if you use the same certificate multiple times, although it does get a bit complicated if you do. If you generate a spontaneous certificate and then send the exact same certificate again later, then
in response to a request?
No, not if you were to send a spontaneous one, not in response to a request. So if for some reason you sent an EA and then you recreated and sent the exact same EA later in the connection, that's complicated to prove. I mean, you can prove it, but it's just, so requiring it to be unique in the context would make it easier.
But high level, requiring that the context be unique in this context of the connection, that's fine.
Sounds reasonable.
Jonathan, ask, go back to the text about if you did not have this one. I think, am I crazy, or is there a not missing in that sentence? If the endpoint does have an appropriate certificate.
Does not, yep. So
that's
you caught the typo.
That's that, I checked the
does
document
not have an
the same way.
appropriate certificate or does not want to return one. Yeah, it's a denial, not a proof of non-existence.
Cool. So will you be able to spin another version of that to include the thing that Jonathan just asked for?
Yes.
Great. And the quicker you do that, then the quicker we can hit the button. So, yeah.
Okay, thank you.
Next, now we're doing the DNS. Now we're doing the DNSSEC chain extension draft. All right. So this button and this button.
10 minutes.
Okay, 10 minutes, sure. Okay, go. Next slide. So this is a summary of what's happened in like 100 email messages on the list. So just to quickly summarize for people who've skipped all that, there's a Dane TLS record that tells you what public key to use or what certificate to use or what CA to use. You can put it in DNS, can be protected by DNSSEC, and it's either in the DNS or not. So if you publish this in the DNS, then it's live. And if your key in the server does not match the TLS, that's like a permanent error. Okay, next slide. So there were some obstacles using TLSA records in browsers. The added latency for additional round trips, the network path not being always clean, and things being stripped or manipulated. So there was a need to put this inside the TLS handshake. So next slide. So there's basically, this is TLSA stapling. So you get a record from DNS, you staple into the TLS handshake, and then everybody's happy to be able to get that information and to use Dane to verify the certificate. So just to be clear, there's no pinning of DNS data involved. It is basically a live snapshot of the DNS data. So the TLS server is expected to regenerate this blob that it's sending in the extension, whatever, every 15 minutes, every 1 hour. So this is not like HPKP. Next. So what is the problem? If the extension is not pinned, you cannot detect whether or not you're under attack or whether you're just hitting a server that doesn't support the extension or whether the administrator turned off the extension. So the problem is if you really want to do Dane and you want to increase the deployment of it in the various protocols, then you need to have a way of pinning the extension. So when this was found out, there were various suggestions of changing the scope of the document, which we believe is the wrong approach. I think that we should actually cover this use case.
So can we get you to hold your comments to the end, Richard, so we can just get through the slides real quick and you can jump back up? Sorry.
Okay. So next page. So basically, these are the options that have been discussed in the working group. One is do nothing. 2, fix everything in a new TLS extension that obsoletes this one. 3, put 20 bytes in this RFC, meaning do not do any pinning, and in the future we can do pinning of the extension. Again, not pinning of the data, but pinning of the extension. Some people thought that was a bit too ambitious, and maybe we need to think about it a little bit longer. So, so we can either do the 20 bytes and define this later, or we can add the 20 bytes fully spec'd inside this RFC. That's okay. Sure.
Sorry.
That's fine. Sure, go ahead. Go to the next slide. So explain all of this. So next slide then. So fix everything in new TLS extension obviously has the problems that that new TLS extension then has to make statements about this TLS extension. So you get like the new extension will pin the new extension and it will pin the old extension. And then at some point, you know, people are going to say, this is just insane. Let's just do one new extension from scratch. So then you're basically throwing all of this document that we're currently working on away, replacing it with the exact same document, except then you add the 2 bytes or whatever the solutions we come up with. So, so that's not a really good solution. So next slide. So we can specify 20 bytes now, which basically mean don't ever pin this extension so people can experiment with it. They can enable it on a server. It doesn't give any commitment to the future of it being there. And later on, we can specify what non-zero byte means, and then both servers and clients can implement the non-zero versions, which we think would be enough to do any kind of extension pinning, but not everybody agreed that that would be enough, and they were a little bit nervous about it. So next slide. So this is why do we think the 2 bytes are going to be enough? Because the DNS already has a TTL and an RRSIG value that specifies lifetimes and protects against replay attacks. And so anything less than a 1 hour TTL doesn't really make any sense, because especially if you look at DS records at the parents, they're not going to expire within the hour. So there's no granularity that you really have within the hour, and there's really no way of needing more than 7.5 years of extension pinning. So 2 bytes ought to really be enough for every scenario we can come up with. So next. But as a compromise proposal, for those who were too nervous that 2 bytes were not enough, and those who were nervous that we couldn't really specify the 2 bytes, the proposal from Ben was to do variable length, where we put in a reserved field so that we're committing to fixing the extension pinning in the future, but then we have a little more leeway. We could do something a little more complicated than setting 2 bytes. Next. And then Ecker came up with another idea of a whole new extension block, set to 0 first and fill it in later. It's sort of the same, it has the same issues as doing a new TLS extension, because this is sort of just a sub-extension inside this extension. So it has the same two things pinning each other kind of complexity. So now the next slide. So the summary is, we really want to have the downgrade protection. We really don't want to reduce the scope to being just DNS over TLS or greenfield clients. We really want to avoid rewriting lots of drafts if it's not necessary. So next slide, we'll just put up the 6 solutions again, and we can discuss about it.
So just to confirm the goals here, Paul, we agree that with the current document as specified, it works fine with the assertive forms of DANE, where you're asserting a trust anchor.
Yes,
there's no need for any of this in the
correct.
case.
If you're not under attack, it confirms that you're not under attack.
Well, no, when you're using DANE in that flavor, even if you are under attack, in that scenario, it's a downgrade attack against TLS. There's typically standard protections against stripping things out of TLS handshake messages apply, and they can't remove the certificate and replace it with a new one. The point of this assertive case is to authenticate even in the presence of attackers. So whether you're under attack or not, that authentication provides authentication. Yeah, I'm not
right.
Okay, yeah, Ben, do you have an idea of what the disconnect is here?
Yeah, sorry to jump the queue, but I mean, there's the question of attack as in, someone is trying to muck around and is in the network, and there's the question of the attack, somebody got a fraudulent PKIC certificate, and maybe they also can redirect your DNS so that the traffic goes to them. So it's a question like, what attacker capabilities do you have in terms of just messing with bits on the wire and stripping extensions out, or actually, being the real other endpoint, that's the TLS server, and sending different bits.
So all the authentication of the DANE part is all really the DNSSEC information and nothing of the PKI information. So all of that is going to be either there or not there. And you're saying that if it is there and it's not mangled with, then you can use it. And yes, I agree to that, but that's not the problem case I'm worried about.
Right, but that is a use case that one could use this for, is to have authentication that didn't rely on the PKI and traditional trust anchors, that was relying instead on the DNS and the DNSSEC hierarchy.
Yes.
Okay, so there is a set of use cases this does address as specified.
Yes, there's a use case for all of those clients that currently do not support Web API could still go running with that, which is currently none, right? So the use case is really small, and if we want to grow this DANE usage, then obviously the two have to live together for a while, right? So your use case is a use case, but it's a theoretical use case, and it's not a real life use case.
I mean, okay, fine. So just to clarify, the concern here is for people who want to use this to use the DANE records to add constraints on the PKI validation, and the downgrade there is a downgrade where you don't have those constraints and you're just back to normal PKI authentication.
Right.
Is that accurate?
Yes.
Okay.
Okay, so Victor and Nico, we see you guys in the queue where you're after Ben Ecker.
Right. So
you were using the term, Eric Riscola, no AD hat. You were using the term "we" there. I don't actually think there's consensus that.
So I didn't mean we as in work.
Oh, fantastic, right. So during the, I'm probably just repeating myself, but during the last meeting, this topic was raised, and I think there was a fair amount of concern about any kind of pinning of this. And I appreciate that you and Victor and Nico don't believe this is the same as HPKP, but I remain concerned that this is similar to HPKP and the concerns are the same. And certainly I remain concerned that having a 2-byte extension which is implied for only time semantics will not be in fact what we need if and when we decide to do pinning. And so I guess my rank order so I'm sure we're going to want to actually close this down, so I'll get it out at the beginning. My rank order is publish the draft as is, Secondarily, publish a draft with a extension block, which actually has like enough room to do the things we want to do. Only after that will we publish things with where our extension blocks have no semantics whatsoever, given that TLS has never done that successfully.
Okay, so I understand that that's your view, but I'm also a little bit sad that in 4 or 5 months of time, you have not come up with anything more concrete and say, like, it feels like there's other pinnings of data, not extension, and it feels that I'm a little nervous, but I haven't really managed to substantiate the claims of why it's actually a problem. Like, I haven't seen you come up with a use case where it's actually a problem that you do this pinning.
Well, yes, and I'm a little sad that I've explained it to you repeatedly and you keep saying that, so.
This is DKG. I think this draft has value as it is. I understand that it doesn't do all the things that you want it to do, but I would really like to try to get something like this working because there are potential clients that don't use the web PKI that could use it. And so by blocking the conclusion of this on allowing pinning, what we're doing is we're defeating those clients that could otherwise use this. So
we as in the opponents of going without modification are not proposing of blocking it. In fact, we have 3 proposals of going to continue without blocking it.
I think this draft would be in last call.
Yeah, there were mistakes made in the process, yes.
Okay, so the reason why people are seeing this, I think, as comparable to HPKP is because the flags that we're talking about adding here that would permit pinning allow the operator of the web server or of the TLS endpoint to make policy decisions about that endpoint that we are not convinced that the operator of the endpoint knows how to make. In general, one of the reasons when we see pinning problems, the pinning problems that we're running into are problems where, hey, it turns out that because I delegated this authority to this, this what I thought was temporary authority, I let this guy run my website right now, they just made a decision based on bits that they set that have implications for my ability to do policy for my domain entirely. Now that might or might not be a good thing, and maybe we shouldn't be encouraging people to do that kind of stuff, but that's why this looks a lot like HPKP. I'm a fan of HPKP, and I'm sad that it went away, but I can understand why people who are nervous about HPKP are also nervous about this, because it's not about a foot gun that kills other certificates, it's a foot gun that kills the entire web PKI.
Okay,
so can we get this draft out the door and then deal with something else later? That would be my preference.
But again, just to clarify, we're asking for 1 or 2 bytes set to 0 that just basically ensures that we will solve this problem in the future and that people are not going to come here next IETF and say, we will never do any kind of extension pinning whatsoever. The draft is, it's an RFC, you don't go home. Because that is what I'm afraid of, right?
I'm afraid of joints that we think we won't, that we think we will exercise that we don't know what they mean, and adding extension capabilities into stuff. Extension capabilities are, we know that that the extra complexity is really hard to get right. And I would prefer a simpler draft because I want to see this thing published.
Yes, but again, the danger is that 4 months from now, we're sitting here with the exact same draft called BIS, with the exactly same explanation of us why we think the 2 bytes are enough, and all of you saying, we haven't really looked into it, and we're sort of concerned, it looks like this other thing, and we can't really decide, and you cannot move forward. So if you can give me some way where we can guarantee to move forward, that would make me happier.
All right, Ben.
Ben Kaduk, with my AD hat on. So I think it's probably useful to remind ourselves here that sort of the core issue is that we have our existing PKX trust anchors and we have our DNSSEC trust anchors. And there's lots of different ways in which you could use one or the other, try to combine them. And sort of the problematic case here, which we sort of have to acknowledge as being a significant case, is the incremental deployment case where you're currently trusting PKIX and you want to add on Dane or DNSSEC in some form, whether that's sort of trying to replace it or supplement it, it doesn't really matter. And the key point is that because you have these different trust anchors, you cannot rely on the PKIX trust anchor to tell you anything about the status of the DNSSEC trust anchor. And that's sort of the key problem. We really don't know how to solve this. And you talk about there's a downgrade attack and pinning will fix it. But pinning is what I would say a partial mediation. And it can be pretty completely partial if you're talking about pinning for 7 years.
and you don't have to worry about it too much in that time, but you probably still have to do some stuff in the intervening time. And so this is something of an unsolved problem that we only have a partial mitigation for, and it only appears in some of the cases. So the question that we have is, well, what do we do? How do we go forward? And there's several things that you mostly listed. I mean, we could publish this document as is and replace it entirely in 4 months with either something that supplements the behavior of this extension, or we could just wholesale do a biz, allocate a new code point, and I think that's fine if we do that. And then sort of the other option is to leave a hole that we will fill in later. And if I take off my AD hat, I really share DKG's concerns that if we leave a hole that we think we know how we're going to fill, like we don't have anybody that's deploying this. It's if we look at other pinning sorts of schemes, the experiences we've had with HSTS, which with HKP or PKP, and with MTA SCS, we've had pretty vastly different experiences with this, and it's really presumptuous for us to say that we can predict what's going to happen, given that there's so many different possibilities. So I think the question that we want the working group to answer is, do we want to leave a hole that we can fill, or do we want to say we're going to replace this with a new extension when we know how to solve the problem? Because I don't think we know how to solve the problem right now.
We're going to clip the line. Victor, you're next.
Can you hear me?
Yes, we can.
Okay. So a couple of things. I heard again a talk of an assertive use case. There is no assertive use case. Paul didn't quite explain. The story is that if you're a server in a WebPKI world and your clients are mostly doing WebPKI, and you say, you know what, I'm going to not have a WebPKI certificate, I'm going to do Dane, you're not going to get too many clients. You're going to fail. Nobody's going to do that. The restrictive use case doesn't work because of stripping, and the assertive use case is undeployable. So the only applications that work for the draft as originally written are those that mandate the extension. And furthermore, as originally written, only with servers that have TLSA records and have DNSSEC. I must remind you that after the draft was pulled, we managed to get some consensus around denial of existence, which substantially broadens the scope of the draft by allowing servers that implement the extension to deliver the bad news that they don't have Dane or don't have DNSSEC. And thereby, the greenfield clients that mandate the extension can interoperate with not just servers that do all three things, but can also interoperate with servers that aren't ready for Dane or DNSSEC yet, but can deliver the extension. So we now have a much broader scope, but we're still scoped only to servers and clients that mandate the damn thing. And we'd like to be able to deploy it incrementally. And deploying it incrementally means that there has to be some value from such incremental deployment. And the value goes away if the thing is trivially strippable. As Ben points out, that the trust anchors from PKIX can't be relied upon to say anything about DNS, and so we need to be able to do this. Now, the other thing I want to mention is, in this context, is that the extension itself. Sorry, I lost track. It's 4 a.m. Apologies. So DKG, right, was concerned about, we don't know how this will play out. I did not hear any similar objections to MTA-STS. Lots of people are very excited about MTA-STS. The draft is getting published. It pins a mechanism. It doesn't pin data. In fact, it pins a little bit more data than this does. It pins the MX records, needlessly copying them, arguably needlessly copying them from DNS into the policy that's pinned by MTA-STS. Here, there's no such need. We're just pinning a capability to deliver the extension. No data gets pinned. This is simpler than MTA STS. It's simpler than STS for HTTP. I know we haven't had the details of that debate, but I can assure you this is STS de minimis. And if you support any other kind of STS and didn't make a fuss about it, I see no reason why there should be a fuss about this. That's all.
So can I just clarify that my concern, Victor, this is DKG, my concern was not about what is being pinned. My concern was about who is doing the pinning. And in the proposal that we have here, the entity doing the pinning is the TLS endpoint itself. In MTA STS, the operator doing the pinning is the controller of the zone, the DNS zone, and the operator of the HTTPS endpoint, right? It's not the MTA itself saying, I'm going to pin start TLS. That's why there was more excitement about it.
Okay. I think we're gonna move on to Nico. Thanks, Victor.
Sam Weiler.
Sam, hold on. Sam, we're gonna go. Nico's next, then Wes, then you.
Hi. I guess you can hear me. So I wrote down some things to say. First of all, to Ben's point, this is a bit tofu-ish. Yeah, I mean, there's no silver bullet for what we're trying to do here. We in a very general sense. For example, if we were all trying to move away from the WebPKI to the DNSSEC over time, right? Eventually we'd want to have a permanent pin for everybody. But that's not what we, Victor, Paul, and I are really trying to do. We're not trying to say that everybody must be on the DNSSEC only and death to WebPKI or anything like that. The second thing I wanted to say was that, again, to the thing about pinning, this is really just pinning the extension. I think this is completely different from all the other pinnings, except as Victor just pointed out. The fact that the user agent or whatever client would be doing pinning of the extension isn't very interesting, I don't think, right? Because it's the same thing in SMTP or whatever. Someone has to do the pinning on the client side, and it's just about the extension being present. You can start out without DNSSEC. You can start out, you can add DNSSEC, you can then add DANE, you can then remove these things. And as long as you have the extension there, it just works, right? It does create a problem if you want to be able to go back to an earlier version of your server that doesn't implement the extension or whatever. But I mean, I don't think that's a problem. It's a very, very simple extension, since on the server side, all it really does is carry data. And most implementations, I gather, will be getting that data asynchronously in a background process. The last thing I wanted to say about the 2 bytes is that, it's speculative in one sense, but it isn't really speculative. We know what we would put there, right? And we know that we're going to write that draft. And, unless unless there are people who are opposed to the idea of pinning under any circumstance, as opposed to, like, are you guys opposed to having the pinning at all ever, or what? Because if you're not, then what's the problem with these 2 bytes, right? Like, we're not saying put the pinning in there now. However, if you're not opposed to pinning, why not add the pinning functionality now? All we need is the 2 bytes and the semantics. That's it for me.
Okay, thanks, guys. We're gonna have to get everybody to be conciser. Thanks. Wes.
We'll try, thanks. Wes Hardiker, ISI. A couple of things. I mean, to me, extension pinning is extremely different than data pinning, so there's not a whole lot of correlation between the two, but I understand the nervousness of it. The thing I worry most about is that when you rush a document through because it should get out the door immediately, that you end up with a greater complex situation in the future. So specifically, when and I'll cut out some stuff. Look, the way I think that we have the avoiding complexity, right, is the worst thing that you could do is create 2 extensions that have to mitigate how they interact with each other. That is much more complex than dealing with one extension field that may or may not ever get used, or defining pinning in the future. So in terms of optimizing for least operational complexity in the future and implementation complexity in the future, it seems to me like putting in an extension that basically says, if you see this extension and it's empty, regardless of whether it's 2 bytes or optional length, you don't do anything, right? That lets the protocol go forward as is. We get to define the aspect of it later. And it leaves a space so that we can put it back without adding the complexity of having multiple version interactions. We already have that now. Otherwise, we're going to end up with this thing die as well to get rid of the older extension, right? Now, the second option is to fill it in now, but I'm not sure based on the consensus. That was actually, filling it in now was my original preference, but listening to the room, there's not consensus on that. So I would option to leave it in as a blank field for the moment. And I'll cut it there.
All right, Sam, you're next.
Sam Weiler. Could, not should, could, if this working group didn't persisted at not wanting to do an extension here, could we fix this in the DNS? Could you steal enough bits from somewhere in the DNS to signal the pinning in a DNS record?
No, because the whole idea is that, for instance, you might get a service provider that strips all DNSSEC records, so you cannot get anything certified through.
I thought this was pinning from when you got the first one.
No, but the data you're pinning is DNSSEC data that presumably you couldn't get from your local transport, so your own resolver can't get to it, and so you're getting it via this TLS extension as a sort of workaround for. So it's just a different transport of the same data. So I mean, unless you want to do like DGB type, like overlays in DNS with A names or whatever, with A records, you wouldn't be able to do any of this.
I'm not sure I believe that answer.
Okay, well, we
should talk more.
Ecker.
Yeah. So I think there are two questions. Eric Scrolla. There are two questions. One is if pinning is good for this, and the other is if pinning is good for this, should we, how should we proceed? My sense is there's real concern about whether pinning is good. You asked for some reasons. First of all, as I said, pinning is quite brittle in deployment. And even if you don't think it's brittle in deployment, we solve the problem of takeover. And I appreciate that you think that you can solve the takeover problem by publishing your new denial of existence records. But that takes a server which previously had no capabilities to do DNSSEC or any of these extensions at all, and forces them to do mass upgrades just so they can publish the record. It's completely unacceptable from any operational perspective. But maybe it's possible pinning is good. We can study that problem. I'm going to be skeptical. I've heard a lot of people being skeptical as well. So then the question becomes, what's the appropriate way to deal with the potential of pinning is good? A number of possibilities here. One is we could just hold this entire draft until we resolve this problem. Another idea is we could leave a placeholder in this draft. So then the question becomes, what kind of placeholder would we leave? Now, your proposal, I believe, is you want to leave a very small placeholder, which only has 2 bytes and has some unspecified, but almost certainly time semantics. Real-world deployments of these kinds of things actually need more than those kinds of semantics. You talk about, for instance, maybe having the ability to warn when there are problems, so you can actually do a progressive rollout and see if you're causing more problems. So 2 bytes doesn't leave room for that. The next proposal we have is to have sort of blank unspecified bytes. As I say, we actually tried this in TLS 1.0 and had a blank thing at the end of client hello, and it caused enormous amounts of rollout problems. So we spent an enormous amount of time trying to build protocols that we could actually grease, so we could find out if people have misimplemented things they're supposed to ignore. And what you're proposing to do is re-bring us back into the situation where you can't grease. So in other words, basically, like, if we're going to do something, let's do something that actually defines it, or do nothing, not like have like a blank field that like somehow we have to fill in later.
Adam, and then Richard, and then we're closing the line, Victor, sorry.
So Chris Nacio, Carnegie Mellon, to Eric's point, it's not clear to me that, if you do zero out the bytes, you actually have to solve it. Like, it gives you the time, right? So if I feel like that's a false choice where, reserving the bytes now and specifying them as 0, like the working group can pick that up later and decide that, you know what, Eric, we looked at the problem and you were right. We shouldn't do it. We can just leave them 0 forever. I'm not sure what the downside to that is, other than, someone might feel the urge that, boy, it's 0 bytes, we should use those for something. I mean, 2 bytes of protocol inefficiency doesn't seem like the end of the world to me when we're moving, some of these certificates and stuff around, right? So it's not clear to me how reserving that, assuming we can come up with some kind of useful mechanism that we can define, is a problem.
All right, Richard.
So one clarification and one piece of argument. So wanted to clarify that this incremental deployment issue that Victor raises is not an issue. If it were an issue, we wouldn't be able to do this delegated credential stuff, which requires switching between one modality of authentication and another modality of authentication depending on what the client supports. You can do exactly the same thing with this extension. If the client advertises that it can do DANE-based authentication, you do DANE-based authentication. If it doesn't advertise that, you use your regular old PKI cert. So there is no
not if there's no pinning. No, that's not, I don't agree. If there's no pinning, you do not have a way of choosing your PKI system. You can only choose the one that we allow or the one that we maybe let you allow when we feel like it. That's not a real choice.
You can have clients opt, so you admittedly servers do have to do the DANE thing and have a normal PKI, have a DANE asserted certificate and a normal PKI.
So if they do DANE certs, they need pinning because otherwise they don't do DANE certs. When you say they do DANE certs, you cannot say they can do sometimes DANE certs and sometimes not.
That it can verify the DANE asserted certificate. And in that case, when the client opts in that way, the server can present that certificate and use that to authenticate.
I'm sorry, now you want to move things to an EKU or something? I don't understand what you're doing now.
This extension is advertised in the client hello, otherwise the server couldn't send it.
Right.
And so when a server receives a client hello with that extension in it, that's the client saying, I can verify a certificate that's asserted.
Yeah, but the server can decide not to send that at any point in time in the future. So there's nothing you can do with that information unless there's a guarantee for it.
I mean, the server could choose not to send a certificate at all.
No, this is the same as saying your browser sometimes can decide to disable 500 CAs in its internal search. You're not letting me speak,
so.
The case that Richard was using as an example is still using the same trust anchor.
So no, the case I'm talking about is where you are trying to authenticate and you're not trying to bind yourself to a specific type of authentication. So it is the case that DKG mentioned where I just want to use a DANE asserted certificate to authenticate. I don't care that someone might be able to get a PKI certificate with that name and use that to authenticate. That's not the thing I'm trying to address with this extension. I'm trying to use this to extend the set of authentication options I have, not to rule out authentication options.
I thought you were comparing this to like a, not the exported authenticator, but like the delegated credentials. Thank you.
Well, you're making a new use case instead of addressing the problem in our use case.
I am saying there are multiple use cases here. As DKG said, this addresses a class of use cases and it does not address certain other classes of use cases that you care about.
Rich, we clipped the line. Okay, so we have to figure out.
Sorry, so that was just my preface. Let me briefly make the point I really wanted to make here, which is that people have been making these future-looking statements about like what happens if we do nothing here. The thing I've learned about this, because the way this discussion has been helpful to me, is to underscore how much we screwed up DANE, in the sense that we conflated two very different use cases. We took this assertive use case where you want to do one thing that is very different from this restrictive use case. And the fact that we're having these, we're talking past each other in this way is illustrative of why it's dangerous to do this. But that points out to me that we have a good chance of success with a future extension, doing this with a second extension in the future, covering the restrictive use cases, the difference in the future. Because there's a clear semantic for developers and implementers. You say you use the extension we're talking about today if you want to do the assertive thing. And I believe we added the text of the document to say, this is the assertive thing.
Okay.
And in the future, it's a short draft.
I understand your
Copy the
point.
syntax.
So basically, you're suggesting to change the title of this document of something like how to use DNS over TLS with a certificate. It is not actually a DANE-based authentication anymore because that's
TLS, it allows general TLS servers to authenticate.
Richard, I let you speak. Can you at least let me finish my sentences and then talk? Thank you. I'm saying that you are not actually addressing the DANE use case, and if you're removing that from the scope, you should remove that from the document title, from the document abstract, and you should say this is only for these specific payloads that are not bothered by downgrade attack.
This phrase you're using, DANE use case, is not a thing. There is not a DANE use case. There are at least
Then
two
if you're
Dane
not
use
covering
cases.
all of the Dane use cases, you should specify that specifically in the document.
I believe, I'm looking back to my co-authors here, I think we added the text to the draft in the after when this was discussed 4 months ago. I think we added the text to the draft to downscope it to only the assertive cases. I'd be totally comfortable with that restriction and clarifying that semantic.
Obviously, some people are not, including me.
Well, but we were talking earlier about things we were disappointed hadn't happened in the last 5 months. You could have written a short draft that took the syntax here, added the pinning stuff, and did a great job of addressing specifically the restrictive semantics that you care about.
We did that as in the GitHub, and we did provide many, we have 4 different proposals here. Come on, you can't say we didn't try to help you out in coming to an agreement here.
No.
We did all the work. We sent the 80 or 100 emails that everybody complained about to the TLS list. I did not see anyone cooperating to get our use case working.
What I'm saying here is we have 2 use cases. This addresses one. There's a different use case that can be handled in a different document that can borrow a lot from this one. We shouldn't block progress on one set of use cases because it doesn't do the other.
Yeah, so you really just want DNS over TLS.
All right. Awesome. I mean, unfortunately, we're kind of back where we were before. Do either of you have any grand suggestions for going forward?
It would be nice if we did something, potentially decide whether or not to just put this right back in the RC's editor queue to let it move forward, and then do as Richard suggests, just address the different use case in a different draft, or potentially something else. So I don't know if we want to have a hub source to do that particular thing, take that particular course of action. That seems perfectly reasonable to me.
Is everybody following along what's going on here? Have you all read the draft? I see lots of heads nodding. Okay, that's good. So we're not like having it. How many people have read the draft? Oh, a fair amount. A lot more than I thought the last time. All right, so let's just do this. All right, I know. Here comes more people. Yeah, we did kind of close the line multiple times.
This is a separate thing.
Oh, it's a separate thing. Okay,
Not a new topic. This is a process suggestion
fair enough.
for something that has worked in other groups. And since you have another meeting at the end of the week, the chairs could convene a small design discussion with a small group of people to see if you can come to at least an understanding of where exactly the tensions are.
So we kind of tried to do that. We did it on GitHub. It kind of devolved it before and
In
it came
person,
back.
face to face, same room and a whiteboard.
Are
Just a suggestion.
So we're in this like painful situation where we're having a deadlock essentially, and I am not entirely sure what to do to progress this moving forward. Ben, any chance you could lend some ideas here for us?
I mean, so I agree. We're kind of stuck as is, given the information that we have right now. I am not comfortable publishing the document that's currently in the ISG editor or an RFC editor queue. Like, I don't think we can publish that as is. Whether we add some additional text to it and say, try to describe what the issues are and what use cases we think is a good solution for and what use cases we think it's not a good solution for. I think there's some potential for that to be a way forward and get something publishable. I mean, I think there are other options open for the working group if people want to leave an extensible whole that we think we can use, but like I don't have a great sense for, like, I was at the front of the room, I couldn't see what heads were shaking or nodding as people were talking with my client. I don't know if you have a good sense or not.
No. So what I think I've heard is that we're going to yank it out of the RC editors queue, and then, I mean, life
If you want a major change, working group last call, respin it. That's what I would do.
And when we have two strong camps that are like, one wants to do one thing and one wants to do another, we don't do well in this, unfortunately.
Yeah, I mean, I may part ways from Richard here, but I don't think this document has working consensus at this point. I don't think it's going to have consensus with the, with the proposed denial of existence changes either. I don't see, I think obviously we can't publish that as it is, but I also don't think we plausibly, there's the parts of the PR that everybody agrees on, and I think we can merge those perfectly well, but I don't think, I would be uncomfortable personally having this document published, knowing how strongly Nico and Paul and Victor feel about it. I don't think that's an acceptable outcome either, to be honest, unless we have very strong consensus in the meeting that it's everybody but them, and I'm not sure I'm hearing, so.
Right, and I think it's pretty clear if we don't have working group consensus to publish the document, then the document just has to die. It is not going to be a product of the working group. There are potentially other venues for publication.
So I may be reaching too far back in history here, but we had a hum at the last IETF about this, and there was pretty strong consensus on the side of doing nothing, or the very narrow down scoping, I believe, was the consensus at that point. And we went to confirm it on the list, and that exploded into a big discussion. But I think none of that netted a stronger, broader body of support for making a change. It was just a lot of discussion and people indulging the same proponents on that. So, I would be glad to have another, if you wanted to refresh that here, to have another hum to kind of gauge the temperature of the room. But I'm not sure, we did that once. We found there was strong consensus in the room. And I'm not convinced that the mailing list discussion, though voluminous, actually demonstrated any additional support for the change position.
Okay, I would like to briefly respond to that. Victor and I had actually given a number of issues that we wanted the authors to talk about to the authors, and they did not actually present those points when they're presenting their draft. And so we were only, part of the audience coming up with some items that said why we didn't agree on things. And then there was a hum made. I don't think that was a fair process. And that's why I actually wanted to present here, to make sure that the room actually knows what we're talking about, and we were not just some crazy guy at the mic saying weird stuff. And so that hum from last TLS was the most misleading hum I've seen in a long time.
Paul Hoffman, acting mostly as a tourist here, but interested in this. So I'm not going to make this easier for you, but I do want to point something out that is very different than what Richard just said. I believe that the large discussion on the mailing list caused people to think more and possibly change, just looking at what some people said here and then 4 days later and such, I saw people changing their views. And I'm not going to say in which way or is there consensus or not, but I believe that the old hum followed by the mailing list actually has caused a number of people to maybe switch or to at least have an opinion. So if that helps you on what to do, great. But it's not like we're in the same place we were before, but just louder.
All right, so we're gonna postpone this discussion and come back to figure out something on Thursday. I think at this point, it's pretty clear that we're probably gonna maybe be yanking it out of the RC editor's queue, but we'll revisit this on Thursday. Hopefully everyone will have a chance to meet and greet and talk and maybe see if there's any way out of this hole. Thanks. Next, I believe is, nope. 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 That one? You are next. That one here. Thanks.
So this is actually, whoa, wow. Wow. Normally you have to really swallow it. This is actually a proposal to add a bunch of unspecified bits to the DTLS13 header. No confidence monitor? Seriously? Okay, that's pretty grim. Okay, I really need to see my own slides. I really need to see my own slides.
I thought they were supposed to be down there, and I don't know why.
Yeah.
Oh, that really sucks. Move it.
I'm gonna like get down on the floor, like I'm like, you know, or something. Okay. Right. Now we have no slides, but exactly, is awesome. Okay. So and I still remember back in IETF 101, you know, we had this long discussion about whether or not we should explicitly or implicitly mark the CID. And I think people were kind of like on it, but we finally decided we were going to explicitly mark it. The idea was to mark that it's there, not to mark the length. If you want to mark the length, well, then you can like make a self-describing CID where the first byte is the length. So like really we don't need to specify that. That saves us a huge amount of like, you know, quick style screwing around with like trying to pack the length of the first 3 bytes and like have like, you know, have like only values between 1 and 16 or something. We also agreed that the DTLS 1.3 work might not be quite as mature as we were hoping, partly because of the interaction with Quick. And so we split the work into the connection ID draft would be a 1.2 draft, but conversely, we take all the CID work and move it all the way into the 1.3 draft, as well as just having like a separate draft. But they both used the connection ID extension, and we ended up putting that in the 1.2 draft. The way they did, we can advance that now, and we could just hoist it in by reference. Next slide. So I'm going to talk about 1.2 first, and then I'll talk about 1.3. The big question for 1.2 was basically how do you encode that the CID is present? And the 2 things that were floated at the time was a bit in the length field or having shadow content types that meant, you know, I'm like an application data message, but the CID is present. We were concerned about like whether or not having the length field, you know, suddenly say that like the packets were, you know, were 65,000 octets long was going to like make middle boxes sad. So we decided not to do that. And so we came up with this content type hack. Turned out that we actually is required defining 4 new content types. And minimum you need 3, maybe you don't like heartbeat, but still it's 3. And that started to make, like actually upon reflection, that started to make people a little sad. Starting with Martin Thompson. Oh good. So now I can like not do this. Next slide. So Martin on list suggested that we basically suck in the TLS 1.3 framing, where basically what you do is allocate 1 extra code point, which is just like, this is like the TLS 1.3 style encrypted content type plus a CID. And then this real content type would be inside the AAD wrapper. And of course you get padding for free, which is nice. And there's no, and you don't need to ever allocate like more code points because you're not chewing up any more code point space because it's all internal. And the reason why we're being stingy about code points here is because of this problem in muxing with SRTP and other things. So the code points are pretty scarce. So that was Martin's design, which I think is actually not bad.
Yeah. So Martin Thompson, one thing I wanted to point out here is that we have 7 left. And you're taking 4 of them.
No, I think you persuaded me that we shouldn't take them all. Yeah. Now we can just heartbeat because like heartbeat is so well loved. Right. So and the good news is is that if you do this, then the remaining code points become re-available to you. So you're chewing up 1 code point that basically says, listen, I got no more code points. You know, I've got plenty more room. So that's nice. So after reading this, which I thought was a pretty plausible proposal, I was like, well, maybe like this is too much for people to swallow. So maybe there's another way to do it that is like less hard to swallow. And so my alternate design, next slide, is basically to do the same thing with a marker content type that means the CID is present, but then have later outside the encryption boundary have a true content type field, which is just like the actual content type. And so this is basically like, this is conceptual like Martin's idea, but doesn't involve encrypting it. So like, obviously that's like inferior from a security perspective, but it's like easier to implement. And so like, you kind of have to decide like, you know, am I trying to make 1.2 better, or am I just like 1.2 kind of sucks and I'm going to like have all the good stuff in 1.3. So I think like either of these would be viable. I don't feel strongly about it. I don't think Martin feels strongly about it, but we have to have one or the other. And so I don't know, like let's just decide this real quick and like I'll scribble in the draft and we'll be done with that piece. I guess I think I personally prefer Martin's proposal. I think it's like why not do the right thing when we're in the game? But if anybody thinks Martin's proposal is like too much work, then like, you know, this is available too.
Thomas, I might have an alternate design here. I might have a third opinion.
Okay.
Which is, we go back to the original problem, which is the fact that the way the 1.3 header is laid out at the moment implicitly reserves to the fifth code points. That's why we end up with 38 minus 32 code points, the problem that Martin is saying. So if we instead pin one of these bits, of the reserved bits, say bit 7, or say equivalently, we instead of doing 011, we do 0110, we right shift the C and the L bits and we reserve 2 bits. Then we get back 2 to the 4th, right? So yeah, we get back 16 code points, sure. which solves the problem. I think it's because 16 back is plenty.
Sure. The problem is now we're actually running quite up against the limits on the length field. On the packet number length field. So how long is the packet number length now, Martin? Is it 13?
We have 001, and then we have 2 bits ahead of that. So we have only 10 bits in that shorter sequence number space.
Right. So like, I'm not really one to give any more bits.
10 is pretty bad already. I mean, it's probably good for a large number of use cases, but it's not. People are going to be forced into the longer.
No, we only have 1 left. No, the unified thing has 2, doesn't it? Is it 20? I thought it was 16. We're just. Oh, you're right. You're losing a flag bit. We're not losing a. Actually, can you scroll forward? We have the thing on the slides. Keep going. So we have the diagram.
That one?
Yeah. So we have 14 bits of. We have 14 bits. So you're going to take away one of our flag bits, right? That's your proposal.
Yeah, I want to take say 7th in the first byte.
You want to take away the one that's X's, right? So like, I want to make TLS 1.3 better, and I don't really care very much about TLS 1.2. So the fact that you have to like pay 1 byte on TLS 1.2 to have connection ID because you don't want to move to 1.3, like, it really doesn't move me. Like, this is like a piece of extension points we have. Why should we give it up just for 1.2?
This is Hannes. Thomas, we can't use this byte because this is the 1.3 header. We are like the problem here is for 1.2.
No. The problem is maximum. The thing that this grabs this header format grabs bits that are conflicting with the maximum scheme.
So I'm with Ecker there that if it's not as ideal for 1.2, I think that's acceptable because of like with the whole effort of moving forward to 1.3 anyway. So like shaving off the last bit there.
And we had proposals to always inject like an extra byte just so we could have this like bit sit here. So like I don't really think that's like
One thing, I think between the 2 proposals that you've done, Martin's and yours, I think I prefer Martin's because yours grab 1 byte more.
No, these are the same. They have the same expansion size. Yeah.
So
I think Martin's is better, but like.
So the difference here is fundamentally where that byte goes. Whether it goes under encryption at the end, which is what we have for the TLS 1.3 record layout, or whether it goes outside of encryption before the AAD. So it's a wash.
Right. DKG, do you want to? I'm surprised you're not saying you want to encrypt it. I mean, I'm trying to close the issue. So if you think it should be encrypted, like, or do you not care?
Yes, I think it should be encrypted. This is DKG.
Thank you. I could just pretend to be you. I'll get a bigger beard. So I'm gonna write this as like the what Martin's proposal, if people are not unhappy. Or not incredibly unhappy.
That one?
Yep.
Okay. There's nobody like screaming, no, hell, go away. All right, cool.
Okay.
Sold.
Next slide. Okay, so I'm now a new person, speaking for a different group of authors. This is DTLS 1.3. So this actually has like almost exactly the same topics as previously. Next slide. So as I said, despite my previous principles, we're going to put some extra flag bits in here because we just like needed some flag bits already, and now we have some spares. That would not be my ordinary preference. So we discussed this unified packet format that basically is sort of vaguely quick inspired, but not entirely, that gives us one long enough sequence number, also doesn't interfere with any other code points, and also gives us room for these two flag bits that tell you whether or not the connection ID is present. Okay, so like the way to read this first word is the things that say 0, 0, and 1 actually are 0, 0, and 1. The C says a connection ID is present. The L says the length field is present, and the X's are reserved bits, which might be something in the future. And I can't remember what we wrote, but what we should write is if you receive these bits and they're set to something else that you didn't expect other than like 0, and there's no extension telling you, then you should choke. Unless David thinks we should grease them, which might be a possibility. You think we should grease them? Should we grease the bits? Okay. Well, grease, right?
Yeah, so Martin Thompson, the approach we've decided to take in Quick is that you set them to random values and
Okay.
you negotiate the
Good, right, so they're meaningless unless they're negotiated and they're greased.
Yep.
Okay, that seems right. And so the next 16 bits are the epoch and the 14-bit sequence number, and then the connection ID and the length, and those are only there if they're present. Next slide. Martin, did you?
Yeah, so I realized that I missed this when I was reviewing this, and I'm sorry for that, but the having reserved bits there is a little awkward.
Okay.
Because you have to worry about this question of greasing. And if you look at this layout, you can potentially only have one bit for epoch in the very, very short header. If you understand that it's only going to be used once the connection is up.
Yep.
And that gives you potentially the 3 fixed bits. The 3 bits that you have there would be the connection ID bit, the long bit, and the epoch bit, and then you have 10 bits of sequence number, which is a lot for a bunch of use cases.
You were just saying it was too small.
It's too small for some use cases,
Right.
but we have plenty of evidence in Quick that 8's plenty for a large number of use cases.
I guess my take on this was if we're going to have one size, it better be big enough for everything, and that's why I got to 14.
Big enough for everything? Is that the assertion?
I think I'm having trouble seeing how you get more. Do you think more than like you think more than that many packets outstanding?
Yeah, it's a large amount of storage.
I mean, there's also these extra bits. You know?
Yeah. It's nice having the one format. I agree, but
that's kind of where I came down.
Yeah.
If you feel strongly about it, I'm happy to.
Yeah.
I mean, we spent an inordinate amount of time in these formats in Quick, and I'm not sure like that profited us very much.
Sure. I'm just nervous about having unused things there that we then have to worry about safeguarding.
Yeah, I'm considering that too, but I mean, we did it in Quick though.
Can we use them for epoch and have a 16-bit sequence number?
And you may have one free bit, or just pin it to 0.
Just make 3-bit epoch.
We could do that. That's a possibility. I don't feel real strongly about it either way. I mean, I only made those. Those were reserved because it was like they're there.
Yeah.
Yeah. Okay, I think Martin and I are going to take this offline, and we'll come back with a mailing list proposal. And like, since nobody else seems to be standing up, I can't imagine anybody really cares.
It's not going to change where the end of the packet is. So.
Yeah. Okay. Just here's a picture of what these things actually look like in practice. Next slide. There's unlike in 1.2 where we're not going to have any way to refresh the connection IDs, 1.3 does have a way to refresh the connection IDs, which is like you send a new connection ID message. That's supposed to have underscores in it. I think I just screwed up with tech. There's also a request connection ID message which says, I'd like some more connection IDs. Has exactly the semantics you think it does, which is send me a new connection ID. This is sort of borrowed from Quick, I think. But it's getting increasingly hard to tell which ideas showed up first in DTLS and which showed up in Quick, to be honest. So many of the same people. So anyway, we have this thing. So you don't need to renegotiate. Next slide. So like all this, I think it's really great to have like connection IDs, but if like you have an increasing sequence number, then like basically the whole thing was kind of pointless. This is definitely a Quick idea. The idea is to steal the Quick style packet number encryption for all the GTLS 136 fixed packets. And I want to emphasize with or without the connection ID. Like we're always going to have this here. It's exactly the same function as in Quick, more conceptually, which is you sample some of the ciphertext and you use that as the input to a pseudo-random function, which you XOR with the which you then XOR with the record sequence number. You can emulate this with counter mode, though it's like not really counter mode, but whatever. There's like a drafty draft PR at this location here. That's what there is. I think this is like a kind of a small improvement to DTLS in the sense that it'd be nice that encrypted sequence numbers are a nice thing, so we might as well have them all the time if we're going to have them at all. I don't promise the PR is good, hence the term drafty draft.
So I haven't seen the PR until just now, but there's a fixed AES here. Should we be doing the same thing as Quick?
Yeah, it should be. I think I just missed it when Hans wrote it down.
And are we planning to encipher the epoch? Because that changes.
I think my answer was no. My answer was to only encrypt the 14 low order bits because then you can read the epoch off the packet, just like the key phase bit.
That makes my suggestion to move the epoch into the first byte a little more interesting because then you don't have to worry about masking it.
It's true, though. I do feel comfortable masking. I do feel comfortable like ending with
It's just a little easier.
ending with not 1-1.
Sure.
Okay. Next slide. So anything else anybody wants to raise about DTLS 1.3? I feel like we're kind of getting down to the wire here. So we haven't implemented this header yet, but we're going to really soon.
So Quick is having a bunch of discussions about new connection IDs, how you manage connection IDs, how you get rid of them, and all of that panoply of horror that comes with that. We should probably not make any serious moves until that settles down over there. I'd like to see the designs be relatively congruent, and this notion of a request connection ID thing is not something that appears in Quick.
Right.
And there's a bunch of
Quick had some sort of like I want you to make sure they're N available or something, right?
This is part of the huge set of discussions we're going to be having on this one.
Okay. Well, I'm happy to hold it. I mean, I agree that there's no technical reason why they shouldn't have the same design.
Yeah.
That said, we are like DTLS 1.3 is closer to being done than Quick is, and so
that's the problem.
Yeah. So I'd like to resolve these issues in Quick so that like we can have the same thing and we can get this out the door.
We should be talking about this this week.
Okay.
Mike's got a proposal for that.
Martin, where in the Quick working group is the discussion happening?
In this building?
No, I mean, there are a bunch because I checked the mailing list before working on the PR and things are, it's sometimes hard to find. Is it on mailing list? Is it in some GitHub repository? Where's the discussion?
So Quick has adopted a policy of having substantive discussions on GitHub, and there are a number of issues that track this particular class of problems. Unfortunately, the discussion is split across a number of different issues because there are a number of interrelated issues that we're discussing. And so I'm happy to give anyone a bit of a set of pointers if that's necessary, or send something to the list. If
I'm just worried that
I know it's annoying, but it's hard hat area, big time.
Yeah, it's also the risk that things are bounced back and forth between the two groups. With like, there's still some differences in Quick after all. So
yeah, we don't necessarily do other groups of service with respect to the work that's going on because of the way that the discussion is fractured. But that's just an artifact of a lot of work going on right now.
Different GitHub issues after all.
Yeah. If you need help with that, there's a discussion. How about we have the discussion here quick and we'll see what turns up there, and hopefully there'll be something that you can use and capture that's a little less.
Yeah. Martin, do you think you could email the TLS list with the issues in quick so people could chase them down easily?
I'll assemble a list. Yeah.
Thanks. Kazuha.
Kazuho, commenting about encrypting the packet number of the initial phase. I don't think that's necessary for DTLS because the data is plain text.
Yes, the plan is only to encrypt once you go into ciphertext mode. Okay, thank you. Yeah, the plain text is an old DTLS cruddy header.
Think delegated credentials. I finally figured it out. It only took me 5 sets of slides.
Hi, I'm back. Delegated credentials. Next slide, please. So delegated credentials is a draft that was adopted last year. It hasn't had a lot of action or change. Not a lot of work has been done at the last IETF, but in recent weeks, we've looked at it a little more closely. The motivation for this is to reduce the exposure of certificate private keys to compromise of one way or another of the web server in which that's serving TLS. So you have a server that's serving TLS, and commonly right now, the long-term secret key, the long-term private key of the certificate is held in the memory space of that application that's connected directly to the internet. There's been a history of compromises that a lot of these web servers are written in memory unsafe languages. Heartbleed is the most famous of which. So the idea for this is to reduce the exposure of long-term private keys to this type of vulnerability. So the latest update was mainly editorial. The construction is it is a TLS extension that is sent from the client to the server, and if the server accepts it, we had a lot of discussions about how this is constructed, but the server will send back this structure called a delegated credential, which contains a public key, a date, and a signature algorithm, and in the TLS response. And the point of this delegated credential is that it's short-lived, but this key is used as the key for the certificate verify message. So rather than using the certificate's key, you're using this short-lived key to finish the TLS connection. So the client will validate that this delegated credential was correctly signed by the end entity certificate and that the date is in the valid range. And it's only useful or only to be used with certificates that have a specific object ID that identifies that it is the person owning the certificate is willing to do delegated credentials. Next slide, please. So here's just an overview of the structure and the design. It's a delegated credential is not meant to be a replacement for an X509 certificate. It's meant to be a very limited scope object that allows you to simply swap the public key, reduce the time validity of the credential. And so it has some nice properties in that it's actually bound to the certificate that is signing it. And it has this very sort of simple credential structure that has the signature scheme that it's signed with, the signature, the valid time, the public key. Next slide, please. So in terms of implementation, this is the major progress that's happened is we've built several people have worked on implementations of the current draft. Specifically, there's an implementation in Boring SSL that's nearly complete. A version in Go, TLS Tris, which is a fork of Go's standard crypto library, and we've achieved interoperability between these as well. I know there's also a implementation in Pico TLS that we haven't tested with the latest draft, but we expect to have more comprehensive testing done soon. And if this is on the path to being adopted and secure, then Cloudflare has a plan of serving these for certain certificates starting in fall of this year.
I should ask you this before, but do you have a CA who's willing to give you the code point?
It's pending on It's coming up.
It's waiting on us.
No, this is pending the ability to issue certificates that have this object ID.
Okay.
And there's the next slide we'll talk about.
Oh, I'm sorry.
Question. Yeah. So, this is an old version of this, by the way. I updated this. So there's basically a question in three proposals. Should be 01 or 02. So in the draft right now, there's an object ID proposal that's basically blank. We have been using in interoperability tests, one that's defined under Cloudflare's object space. So the question number one I want to raise here is whether or not we should move to an object ID that is more fit for purpose for this, something that's defined for IETF security, or maybe we should even consider changing this from an object ID to an extended key usage in the PKIC certificate. So this is an open question right now.
So an OID is an OID is an OID. It doesn't matter what ARC it comes out of. If we decide to use an OID, I don't care that it comes from Cloudflare or Certicom or MyArc. Like, it's just an OID. So the real question is whether you want to stick it in EKU or not, right?
Yes, that's right.
David Benjamin. So I could be misremembering, but I want to say EKUs are the one where, like, in practice, a lot of the implementations do this inheriting thing so that you cannot have the child certificate assert an EKU that the parents didn't assert, and that tends to cause problems whenever you add new EKUs. I could also be completely making this up, but I think it was that.
Yeah, Rich, so, no, your memory's accurate, and the values in EKU are an OID anyway. So it's an OID here, or it's an OID in a complicated structure that has interesting inherent semantics.
Okay. That sounds like we should stick with what it is right now, which is just an OID and we'll pick it. Next slide, please. So proposal number 2, this was brought up as a way to ensure that the certificates that are used for delegation are not used for TLS. So there's this TLS feature extension that's used for OCSP must staple. It allows you to have an array of enumerations where if a client sees one of these certificates and the feature is not used by the server, then it can disconnect. So the question is here, should we add an optional TLS feature value for requiring the use of a delegated credential? The advantages of this are that you separate the use of the private key for this certificate to not be used in TLS. So it should not be used in TLS and would only be used for issuing these short-lived delegated credentials. The complications here are that if you are going to serve a website and use delegated credentials and have clients that are both supporting and not supporting, then you need to have 2 certificates and be able to switch between the 2. And a lot of client software is unable to really do that efficiently or do that in practical sense of switching dynamically choosing a certificate. So this would be an option for servers that do have that capability. Proposal number 3, this was raised by Christopher Patton. Currently, a delegated credential is really a public key, so it can be used for any signature scheme that public key can be used for. So in the case of RSA, there's a whole list of these PSS cipher suites with different hash algorithms that you can use. The proposal is to pick one ahead of time. When you're basically creating a delegated credential, bind it to the only one signature algorithm that you can use for that delegated credential. It makes the analysis slightly simpler. It requires you to, if you want to support clients that do all sorts of different signature schemes or want different signature schemes, it requires you to manufacture more than one delegated credential for a given certificate. But it does have a nice property that you have a lot more explicit control over how the delegated credential is used.
This seems like a good idea, but I have a nitpicky technical question.
Yep.
Which extension would control which algorithm was signature algorithm, signature algorithm cert?
It would be certificate algorithms. Yeah, not certificate algorithms, cert.
Sorry, signature algorithms. Signature algorithms?
Sorry, signature algorithms, not signature algorithms, cert.
That is what I
Yes.
expected?
Yes. Yeah, so this would be the signature algorithms extension.
Yeah, Martin Thompson, further to that, the EE cert, not the delegated credentials, but the EE cert that actually ends up signing the delegated credential would be governed by signature algorithms cert. Is that right? It's effectively part of the chain now.
No.
Okay.
Currently,
So both of them would be signature algorithms?
Both of them would be signature algorithms. Signature algorithm cert would represent the signatures in the chain above the entity certificate.
So the expectation is that the delegated credential is effectively consumed by the TLS stack, not by the certificate processing
Yes, absolutely.
logic.
It's all in the TLS stack.
That's the insight that's important. Yeah.
Not the PKI. And it is a little bit confusing. There's going to be two signature algorithms in the delegated credential, one of which algorithm the DC was signed by and which one it can sign, but they're both governed by signature algorithms.
That's what I expected as well. Perfect.
Yes. Subodh Iyengar. To add as well, we also discussed having the delegated credential signing algorithm in the DC structure as well to aid for debuggability of errors when certificate validation fails downstream. That would be helpful.
Yep, that's a good point. The pull request as written does not include the signature algorithm in the explicit delegated credential, just in the signature, the value that's signed by the signature, but having it explicitly in the delegated credential will make debugging easier. If you have a failed signature on a DC, you'll be able to figure it out much more quickly.
Potentially stupid question. Is the certificate verified with a different label, or is it going to have the same label? As in string?
It should be identical.
Sorry, Jonathan Hoyland. So you're going to use potentially two different keys with the same label under...
And this happens for if you're using a different certificate if you have two different certificates.
You're using a different certificate. Sorry, you're using the same certificate verify structure for a slightly different purpose, which means you could potentially shuffle them around or cause problems. Or
the purpose is the same. It's the key that's different.
okay, thank you.
Okay, next one, this is a proposal that came up through discussions. Right now, the draft supports TLS 1.2 and TLS 1.3. This proposal is to just drop TLS 1.2 from the proposal altogether. Considering this requires a new change in the client software, it's natural to assume that all new TLS stacks will support TLS 1.3. And supporting delegated credentials with TLS 1.2 doesn't really serve too much of a purpose in this case.
I mean, and going forward, we have a working group that basically tried to concentrate on 1.3 and not kind of fixing 1.2 stuff. So I think this is kind of in keeping with the other changes and things we've done in this working group the last 4 years.
Yeah. So Martin Thompson, the question then would be, what's the cost to doing this in 1.2? Because if it's more expensive for us to say, you can't do it in 1.2, then I'd be sort of, oh, well, just let it ride. But I suspect what you've got here is an extension. You currently in TLS 1.3 would put the delegated credentials as an extension on a certificate message, which is something that doesn't happen in 1.2.
I think this would simplify the drafts considerably.
Right, so that's the case for this, which is this makes the draft a hell of a lot simpler.
Yeah, we can delete a lot of text with this.
Right.
And text that's not necessarily useful.
And I'm happy with that too.
Okay, so this is something that we've been doing for a lot of these drafts is let's get some actual assurances with cryptographic tools that this is actually a solid thing to do cryptographically. And so we don't have formal validation of this protocol as currently designed. So this is sort of an open call. If someone wants to talk to me, take this on as a project, or talk to people at the working group, this would be a really nice to have if before we do a last call, is to have some type of formal validation.
I can't commit with certainty, but we have someone I think can take a look at it. So I'll look into that for you and get back to the list.
Okay, thanks. Daniel.
All right. I think I'm late to this conversation, so forgive me if this was answered a year ago. Am I missing something, or is this not useful until it has universal adoption? If a client doesn't support this, what's the service fallback behavior?
So in the draft, we described the service fallback is to use a remote key type of mechanism, which has a pretty stiff latency penalty. So hold your key in another location that's not on the actual machine that's using to terminate TLS. Okay, that's it. Any other comments or questions? Okay, thanks.
Great. Jonathan, you're up.
Okay, I'm Jonathan. I just want to talk about layered exposed authenticators. Next slide, please. So one of the things, I did the formal analysis of exposed authenticators, and one of the things it says it doesn't do is provide joint authentication of multiple certificates. So if I send multiple EAs, I can prove that I control them individually, but not together. And so what it actually means is joint authentication would mean that all EAs were generated by the same actor. Next slide, please.
Hold on, I think, Ben, do you want to interrupt?
Oh, please.
Yeah, I was just going to ask, is there a formal definition of what you mean by jointly authoritative, which I did not see in the draft?
I haven't included it here, but joint authentication means that you can prove that all of the all of the EAs were created by the same entity for each side, obviously. The client ones aren't created by the server or anything. Next slide, please. Okay, so generally you would expect this not to be able to happen because only one person can write to the server side of the TLS channel or whatever. However, there's actually a bunch of different scenarios where multiple people could be writing to the channel. If you have a static RSA key exchange, then it could be some middle box, an attacker who's compromised the server certificate, a CDN coalescing multiple keyless SSL certificates together, or if you, and this was suggested to me last night, if you have a server, a resumption, then you can, the resumption master secret might be passed around within a data center, and so that multiple different places could accept the resumption other than just the original server. Next slide, please. So I propose an extension. The previous certificate request context is now not necessary because it's guaranteed to be unique. But basically, you just put the previous finished in the certificate request, and if it's echoed back, it means the server, or sorry, it means the sender believes that all of the previous certificates are valid. So this is not quite the same thing as joint authentication because it's it includes the client and the server certificates are all valid. So it means the server has, so if a server sent this, it would mean it has accepted the client certificates as well. But it also only applies to the certificates currently in the chain. It chains one certificate together. It says all previous ones are valid. It doesn't say anything about future certificates. Next slide, please. So one use case could be updating PIN certificates. I can prove that I control the old certificate and the new certificate. I can prove that I've accepted a certificate, and you can provide authentication even if you are being middle boxed. Another use case that was suggested to me last night was, again, you could chain authentications from a resumption. So at the moment, if you send an EA and then do a resumption, you'd have to resend that EA. And now you could make it so that you wouldn't have to resend it. You could just prove that you controlled it. That's it. Yeah.
Just to clarify, does that also imply that every request and authenticator now becomes ordered within the connection?
You would make a chain of them, and therefore they would have to be in order in the chain. Not everything has to be in the chain, and the chain can diverge, and that's still fine. You can have a forest of authentication if you so choose. The only case where that would be an issue really is if you have certificates cross mid-flight, and then one side or the other has to do an extra sign if you need all of them in a chain.
So in the forest case, are the different branches, it's still joined across everything in the...
It's only joined on your branch. So if I have two separate branches, they can have two completely different authentication properties. But it doesn't break the authentication. It's just you can end up with some ridiculously complicated authentication mechanism. I wouldn't suggest that as you should do this, that's more of a, it doesn't break.
So at the HTTP layer, we do multiple requests, and you don't necessarily have to respond to every request, and there's no particular ordering among the requests. So at least in terms of how you respond to them, I would have to think about what implications this has for the secondary search at HTTP.
I wouldn't expect it to make a difference because as long as so if the server's sending them, as long as the server knows what order it's sending them back in, it all works.
Okay.
Can you scroll back again to the actual thing you're doing? Right. So the previous finished is the previous finished that I sent, not the previous finished that other guy sent, right?
It's the previous, if I'm linking one EA to a previous EA, it's the finished message of that EA, whether it was sent by the client or the server is irrelevant.
So, okay. I guess I'm not, sorry, so, that's a very odd design.
How so?
Typically, we don't ask people to attest to random crap that their guy sent across the wire.
Don't ask people to
test to random stuff their guy sent across the wire. So there's an immediate problem I see with this, which is that there's a very easy way to implement this that is completely screwed up. Doesn't the request contain the requested certificate? Is that correct?
The request would usually just contain a request context and then some extensions.
Right. So how am I supposed to know which one I'm supposed to be linking to?
So this is an extension that goes in my request. I put this extension in my request saying link to certificate 3 or whatever.
Right. That's what I thought. Okay, good. And then I send it my response, right?
Yeah.
So what makes me check it?
So, I mean, the draft says you have to check.
Yeah.
And what you do is you'd say, if you include this extension in your response, that means you checked. If you don't want to check, just drop it out your response.
Yeah, I'm just saying there's a very easy way to implement this, which is not to check. So I have a suggestion for how to make this much harder, which is only send the prefix of the hash in the request.
And then it needs to prove that it knows the hash.
Yeah. I mean, or any other any transformation that is non-trivial, right?
Yeah. I mean, you could also grease this, I guess, or test if the server's doing that by sending a nonsense finished.
Sure.
Nonsense
Yeah. People don't do that live, though, right? And also more importantly, if it requires user intervention to generate the signatures, then you can't plausibly grease it, right? Because then you just created a user visible failure.
You just created
a user visible failure, right? So, yeah, I don't know.
So more thoughts required. Since we have like 1 minute remaining, I guess I want to ask, who's read this draft? Oh, actually a pretty good fair number. All right. I think maybe it's a little early to ask for working group adoption, but I think that
I just wanted to get people to pay attention to it.
yeah, fair enough. So go ahead, read. We got time. We have another session. And I think that's it for today, folks. Thanks for your time. And those people that are love DNS SecChain extension, please get together and try to solve our problem. Thank you.
Blue sheets? No. He's got the blue sheet. There's somewhere around.